talked about transformations of the parent function in the last unit, but it's an important enough concept that we really need to talk about it again in Unit 5. So, how do I recognize transformations of the parent function? Okay, the parent function of a line, or of any function, is the simplest form of that function. I think I misspelled simplest. Simplest. I'm not sure I'm spelling that word correctly. Is the simplest form of the function. Every other form of the function is what we call a transformation. We talked in Unit 4 about how lines aren't the only function you're going to learn about in Algebra 1 and Algebra 2. Later this year, we're going to talk about quadratic functions, the parent function and transformations. In Algebra 2, you'll do radical functions, absolute value functions, quadratic functions again, and linear functions again. So this is an idea that's going to come up over and over. The parent function of a line is y equals x. We have a slope of 1, and we have a y-intercept of 0. It doesn't get any easier than that. Okay, so we're going to graph our parent function here in red. We use our straight edge to connect our points. Now let me turn that red and put some arrowheads on it. Okay, now we're going to graph a few of these in blue. So y equals 2x. That means my slope is 2 and my y-intercept is 0. 1, 2, 1, up to right 1. Use my straight edge. And let's turn this blue. And put our arrowheads on. Would you say that this line became steeper or flatter compared to the parent function? And hopefully you remember that as our slope gets larger, our line becomes steeper. Okay, it's definitely at a stronger incline. It would be harder to walk up the blue line than it is to walk up the red line. So we are getting steeper as we go through each of these functions. Our slope for the second one is 4, and our y-intercept is 0. And let's turn blue. Put on arrowheads. And finally, our slope is 6, our y-intercept is 0. Goodness. It's getting hard to draw these. Turn blue. Put on our arrowheads. Now, here you're asked to draw in pencil. I'm going to use black on the smartboard. Our slope is 1/2. Our y-intercept is 0. Do you expect this to be steeper or flatter than all of the other lines we've drawn? Hopefully you remembered that this will be flatter when you have a smaller slope, a fractional slope. You have a flatter line. So up 1 to the right 2, up 1 to the right 2, and let's draw that. to do for the black one is put my arrowheads on. Okay. Next up, 1/4 is my slope. Is 1/4 smaller or larger than 1/2? If you don't remember, check it out on your calculator. 1/2 is 0.5. 1/4 is 0.25. 2 is smaller than 5. 1/4 is smaller than 1/2. Another way to stop and think about it, if you eat half of a pizza, or if you eat 1/4 of a pizza, is 1/4 less or more than 1/2? And it's definitely less. Our y-intercept is still 0. Up 1/4, up 1/4. Use your straight edge. I'm going to extend this line a little bit. And put my arrowheads on. And finally, 1/6. Is 1/6 smaller or larger than 1/4? It is smaller. 1/6. So with this set of lines, we are getting flatter every single time. Whoops. Edit, undo. Didn't quite pick up my line tool correctly. Put on my arrowheads. All right, so as my slope got smaller, as I went down these 3 options, my line got flatter. So, what happens when the slope increases? When the slope increases, the line becomes steeper. When the slope decreases, the line becomes flatter. So we have some more lines to graph. And all of these look to me like they deal with the y-intercept. We're going to graph our parent function in red. Y equals x. So a slope of 1 and a y-intercept of 0. We turn that line red. Put my arrowheads on. Now we're going to do 3 of these lines in blue. Y equals x plus 2. My slope is 1, and my y-intercept is 2. Let's turn that blue. Put the arrowheads on. Y equals x plus 5. My slope is 1. My y-intercept is 5. Again, blue and arrowheads. And lastly, y equals x plus 7. My slope is 1. My y-intercept is 7. So what is happening here as my y-intercept increases? I went from 0 to 2 to 5 to 7, so I was definitely increasing that y-intercept. And all I did was I shifted the line up. So when the y-intercept increases, the line shifts up. We talked last class, or back in the last unit, about how when all you change is the y-intercept, you're creating parallel lines. Lines that will never intersect or cross each other. Okay, for the next set, I'm going to use black since I don't have pencil on the smartboard. My slope is 1. My y-intercept is -3. All I need are arrowheads. Next, my slope is 1, and my y-intercept is -6. Here are my arrowheads. And finally, my slope is 1, and my y-intercept is -5. So as I'm graphing this, I want you to think about what happens when your slope gets smaller, when you have negative slopes. Instead of shifting up, we shift down. So when the y-intercept decreases, the line shifts down. All right, you need a summary and 2 questions for this set of